This is a simple nomogram for the solution of quadratic equations designed by E.T. Whittaker and published in 1915 in his paper entitled A Simple Nomogram for the Solution of Quadratic Equations. It has two straight axes plus this circular one, and it also has a little string attached up here. Let's say you've got a quadratic equation like this one here, x squared minus 5x plus 6 equals 0. You line up the string just right, and it tells you the two solutions of the polynomial. E.T. Whittaker was an English mathematician active around 1900 and not especially known for mathematical gadgets. He was certainly one of the greatest mathematicians at the time working in the English language, mostly worked on what we would now call applied and numerical analysis. He was the co-author of a legendary textbook in analysis, the first real modern analysis text in English. But I'm not here to talk about all his great contributions to the field. I'm here to talk about something that's basically forgotten by history. This thing. This is the original version from Whittaker's paper in 1915. It's a nomogram, or a nomograph, or whatever. This word gets used for a lot of different things, but a classical nomogram is a chart with scales on it that you line up with a straight edge or a string or something. You line it up just right and it solves equations for you. I did a video a while ago talking about some commercially produced nomograms. Now, I've never seen this particular nomogram in any commercial product or really anywhere else at all. My version is slightly simplified, and I tried to make it look cute with these little pink spiky things. Really, that's just razzle-dazzle. It's got nothing to do with the math. The original one looks like this. It was published in a paper that's only 2.5 pages long, and one of those pages is totally taken up by the picture. So you could probably read the whole paper in the time it takes you to watch this video. You can follow the link in the description if you want to read the paper and print out your own nomogram. And don't forget to like and subscribe. Let's say you want to solve this quadratic equation. How about x squared minus 2x minus 8 equals 0? Now, the kids in school learned that there's two ways to do this. You could factor or use the quadratic formula. For this one, you get two answers. X equals minus 2 and x equals 4. But that stuff's for suckers. Get your nomogram. You line up the string with a minus 2 on the horizontal axis and an 8 on the vertical. And then answers are the 2 points where the string hits the curved part. Minus 2 and 4, son! Generally, if you have a quadratic like x squared plus 8x plus b equals 0, you're going to find a on the horizontal axis and b on the vertical axis, and line them up. You know, sometimes there are no solutions, like in this case, x squared plus 2x plus 4 equals 0. When you try to do that on the nomogram, you'll see the string doesn't touch the circle at all, so no solutions. Or how about this one, x squared minus 4x plus 4 equals 0, which has one unique solution. And the string only hits the circle once. Man, they've thought of everything. My version has markings for all the whole numbers 1 through 10, positive and negative. Whittaker's original one has markings for some decimal values too, which makes the curved part at the top into a complete circle. Whittaker described his nomogram as an improvement to an earlier design by D'Occagna, who's like the great OG of nomography. D'Occagna's does the same thing but uses a hyperbolic curve. And Whittaker says in the paper that his design is a little better because it's much easier to make your own. You just draw two straight axes and a circle. For D'Occagna's, you need to draw a hyperbola that's lined up in this very specific way, which is hard to do precisely. Whittaker also describes in the paper some other tricks you can do with this thing. It can also do ordinary addition and multiplication. You take two numbers like 5 and 2. If you find both of those numbers on the circle, then where this line hits the vertical is the product. 5 times 2 is 10. And where it hits the horizontal is the sum. 5 plus 2 is 7. Actually, it gives you the sum, but it's always negative. It's fine. So this picture here does lots of things. Well, mostly one thing, and two other things you could have done in your head anyway. But anyway, it solves the quadratic equation. I think that's great. It's a picture that calculates. And the calculation it does is pretty sophisticated. You know, before widespread calculators and such, nomograms were a pretty common type of computing instrument. This one does the quadratic formula, but D'Occagna and others made careers out of producing different nomograms for all kinds of different common equations. They made books out of them. You want a quadratic? You use this nomogram. You got a cubic? Well, we got a nomogram for that. Here's one for this crazy function which gives the mean hydraulic radius of a trapezoidal canal. Nomograms are actually still used today in medicine. If you search on Google for nomogram, you get tons of recent creations made so that medical types can do quick ballpark calculations without having to get out a calculator and remembering some complicated formulas. I made mine here with a computer, but back in the old days, these things were a bit tricky to create. You got to be smart just to figure out how to position everything, and then you have to draw all the scales perfectly in order to get good answers. This is hard work, but once it's done, manufacturing one of these charts is far easier than making some kind of physical computing device in a factory. I mean, it's just a piece of paper, and they're very easy to use. You just line up the string. Anybody could learn to do that in a minute. You don't have to know algebra or much of anything, really. It only does this one equation, but once you have the chart, it's easier to use than pretty much anything else I could think of. The real power of the nomograph comes from the fact that the hard work has already been done for you. Somebody else did the work of drawing the curves and the scales in a particular way. All you got to do is line it up. The major limitation of the nomograph as a computing instrument is that the equation you're solving basically needs two parameters. Like in ours, the A and the B are the parameters. The coefficients, they might be different every time you go to line up your solution. There has to be just two of those, since our string can only really stretch from one number to one other number, not between three numbers. So if you want to turn something into this type of nomograph, you have to rewrite it using only two parameters. And this was a big mathematical question back in the day, around the beginning of the 20th century. Which types of equations can be written using only two parameters? This was regarded as such a big deal that it appeared as number 13 on the famous list compiled by Hilbert in the year 1900 of what he believed will be the most important unsolved problems of the new century. Specifically, Hilbert's 13th problem was to reduce the general 7th degree polynomial to a two-parameter form. I'm just saying there was a time in the history of mathematics when nomograms were super important, useful for computing, but also regarded as deeply important mathematically. Nowadays they're mostly forgotten, but is it possible that there's a bright future for the nomogram? Not just a cute curiosity, but a real role in the theory and practice of everyday modern mathematics? No.